In a period of global obesity, Nambus companies continue selling the fat as the enemy slogans and associating their products with exercise and health. Almost a third of the world has fallen into obesity and no country has improved its levels for the last 33 years. Countless research has shown that sugar is more of a threat than fat and that exercise is very little for weight loss. Yep, despite all exercise benefits, diet is far more important when it comes to weight loss. This is partly because of compensatory behaviours. The choices we make after the activity that nullify its benefit. So after intense fat-burning exercise, people often have a bigger appetite and eat bigger portions than normal, probably less active elsewhere in the day, and more likely to choose the easier option. But more interestingly, when comparing the energy expenditure of a very active Tanzanian hunter-gatherer tribe with adults from first world countries, no difference is observed, meaning the basal metabolism reduces to support the increased activity-related energy expenditure. This is known as metabolic compensation, so even if you want to use exercise, it might be less effective than you'd have thought. It is known that alterations in basal metabolism can alter cellular metabolism, but as most weight-conscious individuals will both exercise and diet, what effects will these metabolic changes have on muscle recovery? When it comes to repair, the usual response involves a neutrophil invasion of the tissue which promotes muscle damage and produces pro-inflammatory cytokines. These neutrophils will also release enzymes that assist in debris clearance. Classical M1 macrophages then invade and release pro-inflammatory tumor necrosis factor alpha, IL-1 beta, and MCP1, allowing fibroadipogenic progenitor cells and satellite cells to proliferate. The neutrophil population will diminish and satellite cells will begin differentiating. Progenitors will release trophic factors and assist the satellite cell population prior to their apoptotic death, which is mediated by the M1s. The macrophage population then shifts from a high composition of M1 towards a high composition of alternatively activated M2 macrophages. The M2 population then induces satellite cell differentiation and supports progenitor cell survival through IL-10. The satellite cells can then rebuild the muscle fibers and return the tissue to homeostasis. The correct timing of the conversion of the macrophage population is paramount for the effective return of the muscle tissue to homeostasis. Too early and the muscle will not repair correctly, too late and the muscle could suffer from chronic inflammation. As the cellular metabolism of M1s are glycolytic and M2s are oxidative, the changes induced by an altered diet and activity level might be quite pronounced. My investigation aims to understand what the initial changes in diet and activity level could entail for the immune system and overall muscle recovery. This study will be conducted with 4 wild-type mice study groups, 3 on a high-fat diet and 1 on a healthy low-fat diet from birth. The mice will be no younger than 5 weeks old at the commencement of the experiment. Study group B and C will alter their diets prior to a single bout of exercise as shown. The exercise will involve 6 minutes of forced wheel running or treadmill running at high intensity, defined as being in the range of 75 to 85% of the maximal heart rate. For every mouse that performed the exercise will be a control mouse who did not. After the mice have recovered, 5 of those mice and 5 control mice will have 2 samples taken, 1 from each leg, through a diagnostic needle muscle biopsy. They will be euthanized with isoflurane in the presence of an AMP-activated protein kinase inhibitor to prevent the isoflurane polarizing macrophages back towards M1. Biopsies will be taken from another 5 mice from each group in the same manner for the next 7 days consecutively. Each sample will be digested with collagenase and DNase to free the macrophages from the tissue. The macrophages will then be fluorescently tagged with monoclonal antibodies against markers specific to M1 and M2. As they are both macrophages, this can be difficult, but it generally involves choosing markers that are controlled by genes upregulated by one form but downregulated by the other. Some potential markers are listed here. Flow cytometry will allow comparisons to be made between each group, giving information about timescale of macrophage conversion and its relation to dietary changes and increased exercise. There will be limitations associated with this model. The mice are not identical, and so recovery rates, amount of damage, and amount of other unplanned activity will differ between mice, and changing microbiota composition might also influence the results. However, this just leads to more important questions that ought to be answered. There are several other factors to consider, such as the effects of exercise intensity, form of exercise, type of muscle group, or the influence of age and gender. These are all important factors and open up exciting areas for future research. With the ever-growing obesity problem and the healthcare costs associated, the question you should ask yourself is not whether this research should be given approval, but if you can really afford not to.